Hi, welcome to my channel. In this video, we want to solve the following problem. Given triangle ABC, let angle A be 3 theta and angle C be theta. Extend BC to D such that DB equals BC and then connect A to D. Given that AB equals 4 units and AC equals 3 over 2 units, find the length of AD. Note that this diagram is not drawn to scale. And now for the solution. First, let's define the length of DB and BC as y, and then consider triangle ABC. Let E be a point on BC such that angle EAB equals theta and angle CAE equals 2 theta. Next, let us show that triangle CAB is similar to triangle AEB. Since this angle is common to both triangles, and angle BCA equals angle BAE equals theta. By the AA similarity theorem, the two triangles are similar. Since corresponding sides in similar triangles are proportional, we have AC over AE equals BC over AB equals AB over BE. From AC over AE equals BC over AB, we have 3 over 2 divided by AE equals y over 4, or AE equals 6 over y. From BC over AB equals AB over BE, we have y over 4 equals 4 over BE, or BE equals 16 over y. Following this, let F be a point on BC such that angle FAE equals theta and angle CAF equals theta, and then consider triangle AEC. Let's apply the angle bisector theorem to triangle AEC. Given a triangle with these dimensions, the angle bisector theorem tells us that A over B equals C over D. Applying the angle bisector theorem to triangle AEC, we obtain AE divided by 3 over 2 equals EF over FC. Since AE equals 6 over y, we have 6 over 3 over 2y equals EF over FC, or FC equals y over 4 times EF. Since EC equals EF plus FC, which equals EF plus y over 4 times EF, we have EC equals y plus 4 over 4 times EF, or EF equals 4 over y plus 4 times EC. Next, let us show that triangle CAE is similar to triangle AFE. Since this angle is common to both triangles, and angle ECA equals angle EAF equals theta. By the AA similarity theorem, the two triangles are similar. Since corresponding sides in similar triangles are proportional, we have AE over EF equals EC over AE. Cross multiplying, we obtain AE squared equals EC times EF. Since AE equals 6 over y and EF equals 4 over y plus 4 times EC, we have 6 over y whole square equals 4 over y plus 4 times EC square. Taking the square root and solving for EC, we obtain EC equals 3 square root y plus 4 over y. Since BC equals BE plus EC, we have y equals 16 over y plus 3 square root y plus 4 over y. Multiplying both sides by y to clear the denominator, we then move 16 to the left hand side. After factoring the left hand side, we divide both sides by square root y plus 4 to obtain square root y plus 4 times y minus 4 equals 3. We then square both sides to obtain y plus 4 times y minus 4 times y minus 4 equals 9. Combining these terms gives us y squared minus 16, and then expanding the resulting expression gives us y cubed minus 4y squared minus 16y plus 64 equals 9, or y cubed minus 4y squared minus 16y plus 55 equals 0. We solve this cubic equation by writing minus 4y squared as minus 5y squared plus y squared, and writing minus 16y as minus 5y minus 11y. We then factor out y squared from these terms to obtain y squared times y minus 5. Factor out y from these terms to obtain y times y minus 5. And factor out minus 11 from these terms to obtain minus 11 times y minus 5. The entire expression thus factorizes as y minus 5 times y squared plus y minus 11. Therefore, we have y equals 5, or y squared plus y minus 11 equals 0. When y squared plus y minus 11 equals 0, an application of the quadratic formula with a equals 1, b equals 1, and c equals minus 11 gives us two possible solutions: minus 1 plus square root 45 over 2 and minus 1 minus square root 45 over 2. To determine the possible values of y, let's turn back to the diagram. Since 3 theta is opposite BC and theta is opposite AB, we require y to be greater than 4. Since these two values of y is less than 4, we reject these values and conclude that y equals 5. Finally, let's apply Stewart's theorem to triangle ADC. Given a triangle with these dimensions, Stewart's theorem tells us that xw squared equals y squared p plus z squared q over p plus q minus p times q. Applying Stewart's theorem to triangle ADC, we obtain 4 squared equals 5 times 3 over 2 whole square plus 5AD squared over 5 plus 5 minus 5 times 5, or 16 equals 9 over 4 plus AD squared over 2 minus 25. Solving for AD squared, we obtain AD squared equals 319 over 4. Taking the square root, we obtain AD equals square root 319 over 2, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.